Okay, folks, we enter the final phase of this meeting. We're going to go to the conclusions, the summaries. As I mentioned earlier, these aren't exactly summaries of what everybody said. The folks that are speaking are going to throw in their own ideas about things. Each of these is 20 minutes. Speakers, I would urge you to keep an eye on your time so that we can finish on time. And we'll begin with, guess who?
You already took 2 minutes of my time.
You'll get 2 more. Go ahead.
I want to present a summary of the Timescale talks, and I've captured images from the talks. And I'm hoping if I misrepresent what you said, please chime in afterwards. And I'm actually kind of an opinionated fellow. I like to think of myself as a cheerful dogmatist. So I'll tell you my point of view. But anyway, let's start out. We've been talking about this time interval called Kasimovian. It has other names or correlative. We have provincial chronostratigraphies. You see them here. If you look at the Carboniferous time scale, and we just published a paper on the Carboniferous chronostratigraphic scale. I put it up in the Dropbox folder. You really have 4 schemes of how to divide Carboniferous time: a Western European scheme, a Russian, a Chinese, and an American scheme. And right now we use all those. We haven't been using the Chinese names very much in the talks here. I know Shandong referred to the Maupingian. We've talked a lot about Masurian, Des Moinian, Westphalian, Stephanian, Kasimovian. And so the real problem that I think day one was trying to address is how will we finally get a agreed on definition of the Kasimovian that at least the subcommission on Carboniferous stratigraphy advocates. Next slide. Now, I want to talk about this. I led into it. You have to realize, and I'll repeat this, this is very important. The history of chronostratigraphy can be cut in half, and it really cuts around the 1960s when you get the Commission on Stratigraphy, which really began by trying to define the base of the Silurian. But before that, everybody defined what were called unit stratotypes. You see that on the left in the diagram, which is from that diagram's from the International Stratigraphic Guide, which was originally written by Herbig and then later revised by Amos Salvador. So what would happen is, and this is what happened in the Moscow Basin, this is what happened in Kansas, this is what happened in France. Stratigraphers, paleontologists went out, they identified in local sections distinctive units of rock, either distinctive facies and or distinctive fossil assemblages, and then they would call something Kasimovian, and it was a pile of rock. It was a unit stratotype. And what everybody realized is that this created a lot of problems because there were often hiatuses between these piles of rock, and some of these piles of rock were found to overlap. And going back to Bill Berggren, I originally worked on the Cenozoic when I was in my PhD school. And I remember that Bill Berggren wrote a paper in the 70s where he summarized the history of all the Cenozoic stages. And it's mind-boggling. The paper's like 100 pages published. There were hundreds of Cenozoic stages named in Western Europe. And many were found to overlap. And then, everyone would argue about my stage is better than your stage, or let's use this stage, or we're only going to use this stage in France, and we'll use a different stage in Germany. We have similar problems here. We have what are called state line faults. The New Mexico Geological Survey will use these terms. The Texas Survey will use those. So that was replaced by a real innovation, which I think really came out of Britain, which was the idea of a boundary stratotype, where all you would do is define the base of a stage. Then you would define the base of a succeeding stage. And by default then, the base of the younger stage defined the top. And that way you got stages that were conceptually blocks of time, rock time, between these two boundaries. And so there were no overlaps, there could be no hiatuses, as long as you defined your stage boundaries not at a hiatus. And this became what I call the GSSP method. I published a paper a couple of years ago reviewing all this. I criticized the GSSP method. It's not a perfect thing. And I've uploaded that paper if you don't know it. It's in the Dropbox folder too. Next slide. So here we see, okay, the GTS 2020, the Geologic Timescale 2020 just came out. And there's a wonderful paper by Aretz and others that summarizes the current Carboniferous timescale. In fact, Shandong is one of the authors, and Herbig as well. And here you see one of the GSSPs of the Carboniferous, the base of the Visayan, defined at a section in southern China. And so the idea is we're going to have this boundary stratotype. Okay, and my argument, and this goes back to Jürgen Romani, who was the chairman of the subcommission, and he said something that I always, a very famous quote to me: correlation precedes definition. We really have to understand the correlation quality of our GSSP level before we define it. Now, I hate to tell you, there are people who don't agree with that. I've argued with some of the Permian subcommission folks who think, no, we'll do definition, we'll define it, and then we'll figure out how to correlate it. That makes no sense to me. So the correlatability, if that's a word, I'm not sure that's a real word. I was happy to see Yukun Shi used it, because I've used it, and I looked it up one time, I couldn't find it anywhere. But the ability to correlate that signal, okay, and that's the way you want to think of it. The GSSP is a point in the rock, in a section, in a place. And that's the GSSP. The GSSP has what we call a primary marker or a primary signal. That could be the first appearance, we want to believe, of a taxon, a conodont, for example, or it could be a fusilinid in the cases we're talking about here. Those seem to be the only two candidates for a base Kasimovian. The problem is that we know a priori that no single taxon appeared on Earth instantaneously everywhere. We want to believe that the signal, the appearance of that taxon, might have been fast enough that it doesn't matter. We're talking, what, 305, 307 million years ago. Maybe the conodont first evolved in, somewhere in Tethys, and then it appears, in other seas quickly enough that we can't discriminate its diachronaity. But what's been found in many of the GSSPs is that they are diachronous. The signals are later shown to be diachronous. This is, for example, the latest one is with the base of the Triassic is defined by a conodont first appearance, the appearance of Hindiotis parvis in the section at Meishan in South China. We now know that there are older records of Hindiotis. They're technically Permian, and that's a problem. So one way we get around the problem, or we should, is we need multiple signals. I mean, I would argue if we're going to have one point in the rock, we've got to have a single signal. So we'll pick that, say, one conodont, but we got to have other data. We want to have the best GSSP is one that has a good primary signal, maybe not a perfect one, and a lot of secondary signals, or I call them proxies, other data that allow for correlation. That is the thinking now of what's going to make the best GSSP. So when you think about defining the base of the Kasimovian, defining the base of the Gagelian, what I would like to see are sections where we have a good primary signal, we'll agree on that hopefully, and then we have a lot of secondary signals that'll give us greater correlation. Next slide. So what do we need? If we're going to define the Kasimovian, this is what the Carboniferous timescale looks like now. Those are the GSSPs that have been agreed on. We need two GSSPs. We need a base of the Kasimovian, and then we need the base of the Gagelian to define the end of the Kasimovian by default. Okay, and we need to agree on those signals, and then we have to agree on a location. That's the way it's usually played. Okay, next slide. Well, Shangdong Wang, who is the chairman of the subcommission, did a wonderful job of introducing us to this. And we all know now that there really are two possibilities that are being advocated. A lower point, shown here in this diagram, point A, and an upper point, point B. And they're shown here related to the Russian substages of the Kasimovian. Are we going to define an older Kasimovian or a younger Kasimovian, if you will, a shorter Kasimovian at point B? Okay. The signal for the base of the Gagelian seems to be agreed on. It's the first appearance of the conodont Idignathotis simulator, but there is no agreed on place yet. Next slide. Well, Natalia Goryeeva did a great job of introducing us to the Moscow Basin, the neostratotype, the Afanasyevo section. This is the arrow shows the base, the traditional base of the Kasimovian and the distribution of taxa here. Next slide. I think it's fair to say that the Russian point of view is to maintain the traditional Kasimovian, to have the base between the Myachkovian and the Krevakinian. And there is a conodont criterion that's been proposed. And one of the things you have to realize is if you move the Kasimovian base up to the younger level, then of course the lower Kasimovian of the last 100+ years is going to become late Moscovian. The Moscovian will become longer, and our bookkeeping will be messed up because we're going to have a lot of fossils that have been called Kasimovian over the years that are now going to have to be rethought of as Moscovian. So that is the downside to not choosing the traditional base of the Kasimovian, or at least one of the big downsides. Next slide. Our Chinese colleagues Hu and Qi showed us this remarkable section Naching, where there's been a tremendous amount of good work to develop a really important conodont record through the section that bears comparison with both Russian and American conodont records. Next slide. Hu was very diplomatic, I thought. I think I asked him directly what boundary he favored, and he didn't really say, but in their talk, they showed us this diagram where they evaluated 4 possibilities. And it's a little strange because the older possibility is above. It's kind of reversed the way I usually think of diagrams. So the Swedelina sub excelsa criterion is the oldest one here. And they evaluated and concluded that, you see on the right, their subjective rating. The highest score was a higher boundary at the Idignathodus Heckelei first appearance. Okay, next slide. Now, Roscoe and Barrett, and Roscoe in particular, did a wonderful job of showing us this incredible, long-studied, well-studied record of North American conodonts through the interval we're talking about, basically through the Des Moines Missourian interval. Next slide. And I think one of the most important points they made, I think Jim Barrick was making this, is at least in North America, there is a substantial extinction, a substantial marine turnover across the Des Moines Missourian boundary. Now, the Des Moines Missourian boundary, though, is younger than the traditional base of the Kasimovian. So this biotic change, which at least in the North American section is easy to recognize, to me is a very attractive secondary signal. These are a bunch of secondary signals to go along with the conodont primary signal for recognizing certainly the base of the Missourian, which we all agree on. But this to me argues strongly for putting the boundary at a higher point, at a point close to the Missourian base. Next slide. And of course, Jim Barrick made that argument straight up in this slide. You have the extinction of Swedelina, which you could use, and then you have followed by the radiation of the Idignathodus species, and you would pick a conodont event somewhere, perhaps a little bit above Swedelina, but the point is, this is a boundary that has a lot of secondary signals. So to me, it's appealing. It's not just because I'm an American, but it's just, I find it an appealing boundary because it's going to be an easy boundary to correlate, relatively speaking. Next slide. And then Katsumi Ueno gave us a marvelous talk on fusulinids across this boundary. He suggested that perhaps the first appearance of the genus Montiparus could be used as a criterion. One of the downsides of that is we don't understand well as I understand it, we don't have a good handle on the evolution of Montiparus species, who's the ancestor of Montiparus, who's the oldest first. But that aside, there is a substantial change in the fusulinid fauna across the sort of early to middle Kasimovian boundary, traditional boundary. And it is this change. And, if you've ever, you see it in North America, you go from the Bedina dominated fusulinid faunas, the Fusulinidae, to the Triticytes faunas, the Schwagerinid faunas. And this is a big change that's occurring right around the Des Moines Missourian boundary as well. And I think we understand why it happens in some sense. Biologically, it's the evolution of this honeycombed wall, this karyothecal wall, although we're not sure whether it's just for strength or is it for photosynthetic symbionts, or maybe it's for both. So next slide. So how do we define the base of the Kasimovian, right? I think we've agreed, there seems to be stability in the signal for the base of the Gagelian. We just need a place. The base of the Kasimovian, though, is not quite as far along the line. We have these two contrasting definitions. One would, if we make it the younger place, we go against priority and usage. On the other hand, I would argue the younger boundary is more correlatable. So to me, it's an attractive boundary for that reason. Next slide. And we didn't talk as much about some of this as we should, but we need to realize that we need a lot more data just than the paleontological data. The good GSSP would also be associated with any radioisotopic ages, which we seem to have very few of. We do have cyclostratigraphy, sequence stratigraphy, and even the chemostratigraphy, because again, these are proxies. These are other signals that allow us to correlate. If you look at the base of the Silurian, it has a tremendous geochemical signal that helps correlate it in addition to its biostratigraphic criteria. And then finally, I think my next slide. Dare I bring up the Cantabrian with Godzilla in place? So what is the Cantabrian? Is it another name for part of the Stephanian? Here's what I would say to John Knight and Chris Cleel and all the advocates of the Cantabrian. To me, the Cantabrian is a chronostratigraphic concept looking for a definition. It has never been well-defined, convincingly defined in my point. And by that, I'm fine with the Cantabrian as a non-marine paleobotanical provincial stage or substage that's only used in Europe or whatever. But the point is, it needs a definition just like any other chronostratigraphic unit that allows its base and its top to be unambiguously identified, and therefore it allows this block of time that the Cantabrian would represent to be correlated. That's the key thing for the Cantabrian. So I think, having said all that, hopefully I didn't misrepresent anybody's point of view. I will just tell you, I favor the younger Kasimovian base, which would be close to the Missourian base in the North American section, the Kamofnikian base, because I think that's the most correlatable base of a Kasimovian. And I feel bad for the Moscovian. I don't like to shovel stuff. I've lived through the changes of the Pleistocene. You all had to deal with that, where they moved the Pleistocene base down 1 million years. So now all sorts of stuff that was Pliocene for my whole career is Pleistocene. But anyway, I'm done. Thank you.
Thank you, Spencer. Thank you for a very thorough and enjoyable summary. And we have 10 minutes for questions. Let me see if I've got anything in the box there. There must be some question or comment.
Come on, Cantabrian's a fighting word, as they say.
Ron, you're lit up. You have something to offer here?
Yeah, I'm not an expert on this, but we're searching for something that could be a suitable time boundary that might be more better constrained than the biozone boundaries. And I just was quickly looking. I see there's been some work on the Pennsylvanian, actually Carboniferous timescale using magnetostratigraphy, and a number of zones have been developed, much as we've seen for the Mesozoic and Cenozoic record. And I just wondered if anybody has looked at trying to define these boundaries that we're having so much trouble with, these time units, recognizing these magnetic boundary changes in the stratigraphic units, rather than trying to use some of these other criteria we've been discussing.
That's a good question. Let me point out, some of you know that Jörg Schneider and Xiangdong and I and Svetlana Nikolaeva, we're editing a volume for the GS of London on the Carboniferous timescale. And Mark Hounslow has a paper in that volume on the magnetostratigraphy of the Carboniferous. And I've uploaded all the papers that are done are in the Dropbox. Here's the deal with MagStrat. There's two things to say. One, the Pennsylvanian is within what's called the Kiama superchron, right? It's supposed to be an interval of very long reversed history with no particular magnetostratigraphy, which is very different than the Mississippian, where you have a fairly robust set of reversals. And of course, the Kiama lasts all the way into Middle Permian Guadalupean time when the field starts to move again. If you read Hounslow's article, though, he points out there is some evidence of a reversal history within the Pennsylvanian, but it's not a well-documented reversal history. So I would say Pennsylvanian magstrat is kind of in its infancy. And so it's not going to give us something that we might be able to use, say, in the next few years. Okay, that's part one. Part two is other people have suggested, so let's go to the Triassic where we have a very active magnetic field. And other people have wanted to define GSSPs on magnetochron boundaries, which is okay, but the problem is, magnetostratigraphy doesn't give you independent correlations. It's kind of like chemostratigraphy. If I show you a magnetostratigraphic history from the Oligocene and the Jurassic without telling you a biostratigraphic datum or a number, you have no way of really knowing where you are. So there's been a lot of, and that's my argument. It's not original to me against using magnetochrons. Now, having said that, a magnetochron would make a good secondary signal, as long as we know what age it is, more or less, as long as it's near a number or it's near a biostratigraphic boundary. But I don't think anybody in the timescale community, and I'm trying to remember, I think in the Cenozoic, there may be a magnetochron that's been used to define a GSSP. But I know in the older rocks, nobody wants to use a magnetochron boundary as the primary signal. But it is a good point. And I would say to you, and I know Bill's looking for new horizons, doing magnetostratigraphy on Pennsylvanian rocks could rejuvenate a career. You know what I mean, Bill? And having done it, it's dog work, going out and drilling and hauling the water for the drills. It's hard work. It's good physical labor.
I have bad knees. I guess a question that comes up, Spencer, that you and I have talked about with regard to some of these kind of things. Why don't we just find one place or two places or 10 places where there are lots of ash beds, get a lot of dates, find out what animals we can find around the marine animals we can find close to or around those dates, and completely drop the current type of stratigraphy and just simply go to a time-based stratigraphy? Isn't that Hedbergian in its extreme?
No, that's an interesting idea. And in fact, you may know Vladimir Davydov has just published a paper, I think last year, in Gondwana Research, arguing just that we're, at least where we have the numbers, he argues, so a good example is we have a ton of numbers right around the Permo-Triassic boundary. In South China, we have a lot of ash beds. So he argues for that. Yeah, I mean, I'm not averse to that, as long as the problem is where you don't have the ash beds, what do you do? And that's why you'd have to have some other, so you could make the ash bed number the primary signal, and then you would have some biostratigraphy. So you got to think about the GSSP is easy. I can go out, I can make a GSSP for the Kasimovian up in the mountains right near me, because I know where the base of the Missourian is, right? But the problem is, would I be able to correlate that? How do I correlate that everywhere I can get to? That's the question.
Herman, you have a comment?
Yes. Actually, I think this goes back to the contrast between catastrophism and uniformitarianism. An old story in geology. But let's take an example. If you want to define the boundary between the Cretaceous and the Tertiary, do you pick the time of the impact, or do you pick the time after things get established and you get a clear paleontological signal?
Well, they've picked, that the GSSP for the base of the Tertiary, the base of the Paleogene, is the iridium layer. So, that subcommission picked the time of the impact. The argument, and some of you may remember, Bill Berry wrote a paper on this many years ago, arguing that the iridium layer was a uniquely synchronous signal that could be found, and it's found in non-marine and marine sections. So it was a very appealing signal. The extinction of the dinosaurs, which may have occurred at the impact or just before, the reestablishment of, what's the thinking that the vegetation gets decimated for a few decades and then it pops back up. Those are biological signals around that iridium layer that make it a very correlatable signal. But your point is a good one, Herman, too, that the catastrophist, the sort of hiatus-laden rock record, if you will, And that's still a big idea out there, right? I mean, my take, you know, when I worked in Kazakhstan, all the Soviet stratigraphy I dealt with was very catastrophist. It's what Derek Ager called Marxist stratigraphy, you know, where, you know, because, no, seriously, because you had the break, and then you establish the biota, then you have stasis, then you have the break. You know, this is kind of the Karl Marx view of history, which was incorporated into Russian stratigraphy. But then you have Schindewolf, you know, classic German thinking in the same line, right?
Yeah, I don't think it has anything to do with Marxism.
No, I agree. But it's ironic. It is Karl Marx's view of history. I'm not trying to accuse him of that. But that's what Ager was pointing out, that it's ironic that the way Marx thought history, human history worked, is kind of the way we long thought about the rock and fossil record. That there were these periods of change, these upheavals, whether they were orogenic or whatever, followed by establishment of a biota, then the biota persisted, and then there was another change, right? And what's happening now is we're trying to get away from that. All those classical stages were at the, you know, kind of catastrophist stratigraphy, if you will. And now what we want to do is go into some rock column where we think it's continuous, and we want to look at some conodont lineage. I mean, and you know, I don't want to get into this because I'm not a big fan of conodont chronomorphoclines and all that, as you probably know from what I've written. But you know, we're looking for something that's just a timeline without breaks. That's our GSSP level.
Yeah, and I think there might be, this might have been influenced by uniformitarianism and getting away from catastrophism, but I think it might be wrong. The clearer signal is where there were fast changes in Earth history, and there were times of faster change, and then intervals of slower change. Why put the boundary into an interval of slower change where it's much more difficult to see?
It's a good point. Who would answer that? Would Shangdong Wang explain it, or maybe one of the conodont specialists? No, nobody wants to grab that.
We only have a minute anyway.
So 1 minute, let's start arguing about the Cantabrian.
Oh.
No. You have other things that's similar to that we could argue about. Okay. Thank you very much, Spencer. Thanks.